right. So let's get going. I'm going to open the chat so that I can see anything you guys post. There we go. There we go. And let's go. Okay. Now, the first thing we're going to speak about when it comes to simplifying algebraic expressions is what we call substitution. What does substitution mean? Is there anybody here who knows what substitution or substituting means? That means we're going to take all of the numbers that they've given us here for A, B, C, and D, and plug them into our algebraic expressions. Okay. Remember, expressions do not have an equal sign in the middle of them. It is just an expression. So this means wherever I see an A, I am going to substitute a 4. For B, I will substitute a -3. For C, it will be 12. And for D, -2. So let's get going. Let's start off with number A. Well, letter A. You guys understand what I mean? So wherever I see an A, so I see an A here, it's A squared. I recommend when you substitute, you always put brackets around, and we'll see why just now. So it's 4 squared minus, now B is a negative number, okay? It's a -3 all squared. Do you see why we need brackets? The negative is part of the squaring. And then you say plus C is 12 all squared, and minus, again, we have a -2 all squared. Okay, equals. Now, what is 4 squared, guys? 4 squared, we're starting off with a little bit of a warm-up. What is 4 squared? What will that give us? 4 squared. Welcome to everyone who joined after I greeted. 4 squared is 16. Remember, 4 squared means 4 times 4. Okay. Minus. Now, we have a -3 all squared. This means -3 multiplied by -3. And 2 negatives will give you what type of answer? Nice, Butlali. This will give us a +9. So this is why I needed brackets, okay? Because this is going to give us a +9. You'll see what's going to happen here. Plus, what is 12 times 12? 12 squared. 12 squared will give us, nice, 144. Minus -2 all squared. -2 all squared gives us, what does that give us? Nice, Putlali, +4. Now, these negatives outside and this positive inside my bracket, what are those going to give me? A positive and a negative give me a negative. So then I'm going to rewrite this with the correct symbols. So this is 16 minus 9 plus 144 minus 4. Okay, what's 16 minus 9? 16 minus 9. Let me do this so that I have some space. 16 minus 9 is 7, and 7 plus 144. 7 plus 144. 151 minus 4. Minus 4. We're on the last step. 147. Thank you, Butlali. Simple and straightforward, right? Now let's look at B. Okay. This time I have a 2AB plus CD. What does 2AB mean? What are we doing with that A and B and the 2? Which operation does 2AB imply? If they're just next to each other, then it implies that we are multiplying, right? So this is actually 2 times, and our A is 4, times b, which is a -3. And this is plus c, which is 12, times d, which is -2. Okay, let's get going. Now let's start with the first 3. Okay, so our big rule that we always use here is BEDMAS, which means we have to start with multiplication before we can add. So let's start with multiplication there. I have a 2 times 4 times 3. I have a positive, and a negative. What type of answer is that going to give me? My answer is going to have which operation? A negative. That's good, Bukhali. That's true. Because a positive and a positive means it will remain positive. But as soon as we multiply it with a negative, it becomes negative. That's okay, Blessing. Welcome, welcome. So I have a negative 2 times 4, which is 8 times 3. That is 24. So my first answer here is 24. Then I write my plus that was in the sum in the first place. So this plus comes from there. And then you open brackets to work out my second part of the sum. So this time I have a positive and a negative number. So then my answer will be what? If you multiply a positive and a negative number, what will your answer be? Negative. So I have negative 12 times 2. Negative 12 times 2 is 24. Once again, we are stuck with this positive, negative in the middle. What does positive and negative give you? A negative. So it's negative 24 minus 24. So we're going further into the negative side of my number line. What is that going to give me? Starting off from negative 24 and getting smaller and smaller. So it's going to be negative 25. Nice, Logan. This is negative 48. Nice. Now let's do C. We're not going to do all of them, just enough for us to understand this concept of substitution, okay? C is 48 divided by, and to remind myself, C is 12, okay, minus 3 times, okay, when you have 2 sets of brackets here, remember I said when you substitute, use brackets, then use different kinds. So I'm going to use a square bracket here to be able to distinguish what I am doing. They mean the same thing. They are all brackets. Okay, so I have my square bracket for the big term that I'm about to work with. So this is A 4 times B, which is negative 3. And all of this is going to be squared, okay? Minus D, which is negative 2, all cubed. Okay, I've rewritten my sum properly with my substitutions. Where do we start here? Look at BEDMAS. Where does BEDMAS say we start? Where does BEDMAS say we should start? Brackets. Do we have a set of brackets that need simplifying inside the bracket? I have a 12 here, but I can't do anything about it. But is there another set of bracket here that I can simplify? And which one is that? Wait, said yes. Which set of brackets needs simplifying inside? It is the second one, right? My big bracket. There we go. Over here. So we can simplify inside the bracket, which means I'm going to leave everything else the way it is, just to keep track of what I am doing. Let me do this. 48 over 12 minus 3. Now I am inside my big bracket. Okay. What is a positive 4 multiplied by negative positive 4 multiplied by negative 3? That is positive and a negative will give me a negative answer. Nice. Thank you, Yonela. 4 times 3 is 12. Put back my brick brackets and I rewrite everything the way it is. Great. We've dealt with brackets. What's after brackets according to BODMAS or BEDMAS? What's after brackets? If you look here, brackets was my first step. We've done it. What does this E stand for? Before division, it is exponents. We have a lot of exponents over here, right? So I'm going to rewrite my division as is over 12 minus 3. Now, I have a negative 12 all squared. What is a negative 12 all squared? My negative is inside the bracket. So that means this will mean negative 12 times negative 12. And that is a nice positive 144. Do not lose marks, okay? If your negative sign is inside the brackets, like so, that means you included when you are squaring. So it's negative times a negative, which is a positive. Great, 144 minus, now I have a negative 2 cubed, negative 2 cubed. That means negative 2 times negative 2 times negative 2. 3 negatives will give me what type of answer? Nice, it will give me a negative answer, and 2 times 2 times 2 is 8. So it's minus negative 8. Beautiful. Now, division and multiplication can be done at the same time. Remember, we group these together. Division and multiplication are grouped together, and addition and subtraction are grouped together. So we can do them at the same time. That means 448 divided by 12. What is my answer going to be? That is 4. I'm going to insert a line here so we can tell that the equal sign is not part of the same line. Equals, this is 4. Then a negative 3 times a positive 144. Firstly, I know my answer is going to be negative. There we go, 432. And then I have a negative and a negative. What are those two going to give me? 2 negatives will cause this to be a positive 8. Great. Now, what is 4 minus 432? 4 minus 432. What will that give me? That is negative 428. And if I add 8 to that, if I add 8 to negative 428, there we go, negative 420. Nice, guys. Okay, I'm going to go up and then zoom out for people who are taking screenshots. Okay, I need to zoom out a little bit more. There we go. Now, can I have a thumbs up, thumbs down? We understand how substitution works. Nice, 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 nice. Okay, that's great. Okay, now let's move on. Now, my second part of simplifying algebraic expressions is to find like terms. Why would we want to find like terms? Does anyone know what we do with like terms? Why are they so special? They are the only types of terms that can be added. Okay, so like terms have the same variables with the same exponents. So not just the same variables, the exponents have to be the same as well. Okay. And unlike terms, that means they either have different variables or different exponents. What this means is that y and ang Apparently, I can't spell anymore, guys. Y and y squared are not like terms. Why? Why are they not like terms? They are the same variable, but what are they missing? What's missing from these two terms that could make them? Nice, Ionela. They have different exponents. This one has nothing there, which means there's 1, and this one has a squared or a 2. So these wouldn't be like terms because they have different exponents. Okay, now let's get to work and identify like terms in the same color. Let's look at 1. 1 has 57m squared, 57m cubed, negative 7m squared, and m to the power of 5. Which ones are like terms? So to make this easier, you can either say number 1 and 5, or number 1 and 3, or number 1 and 2, so that you don't have to type out 5m squared or 5m. Okay. So out of number 1, 2, 3, and 4, which ones are like terms? Let's hear. I have a 1 and 3. I have a 1 and 2. Okay. Anyone else want to add some input there? Botlale has changed. Neo agrees. Okay, beautiful, Angel. Beautiful. Number 1 and 3. Okay, because they both have a M, but they also both have the squared. Did we say anything about the coefficients when we spoke about like terms? Remember, the coefficients are the numbers in front, these ones. We did not say anything about coefficients, so it does not matter what the coefficient is. You look at my variable and my exponent. And in this case, the only two with the same variable and exponent is 1 and 3. Okay, let's look at our second sum to unravel. Let me number them quickly. 1, 2, 3, 4, 5, and 6. Okay, so now we have 6 of them. Out of these 6, are there any like terms? Are there any ones with the same number of B's and the same number of C's? Any like terms? The order does not matter. You look at, does it have a B and does it have a C? How many B's does it have and how many C's does it have? Has anyone found any like terms so far? Remember, you just tell me which number it is. Bogumusa says none of them are like terms. We need more input here, guys. Yonela says 1 and 4. Okay. So does Lenom. Tabutlali says 2 and 6. So does Angel. Okay, let's look at 1 and 4 first. Okay. We have a B squared. And number 4, we have a B squared. Okay, let's check. We have a C and we have a C. Do they have the same variables? Let's first start with variables. Do they have the same variables? Number 1 and 4. Mutlali says no. Okay, but they have a B and they have a C, don't they? Are those not the same variables? They are. So they do have the same variables, and do they have the same exponents at the right place? The B is squared and the C is on its own. Are those the same as well? Yo, English just went south. Yes, so indeed, number 1 and 4 are like terms. Okay, the order does not matter because, guys, just remember, if I have B squared C and C B squared, that's the same as saying 2 times 5 or 5 times 2. Will I get the same answer? If you say 2 times 5, will you get the same answer as saying 5 times 2? Anyone? Are these two sums going to give us the same answer? This one and this one. Okay, what's 2 times 5? No, Yonela says no. What's 2 times 5? 2 times 5 is 10. Okay, what's 5 times 2? That is also 10. Do you see that the order does not matter? So whether your B was first or your C was first, that doesn't matter. What you had to make sure is that the B, both of them had a square, and both your C's had nothing there or a 1. And in this case, that's exactly what we have here. So they're like terms. I also saw some people say number 2 and 6, I believe. 2 and 6. Yes, you did say 2 and 6. So let's check them. I have 1C. I have 1C. All right. Let's check the B's. I have 3 B's and I have 3 B's. Are 2 and 6 like terms? Are 2 and 6 like terms? Number 2 and number 6? Yes, they are. So then not only is 1 and 4 like terms, I have 2 and a 6. Are those all of my like terms? Yes, because if you look at the rest of them, I have a C squared. There's no other place here where I have a C squared, so it's already eliminated. Okay? And for number 5, I have 1C and 1B. None of them have 1C and 1B. It's just number 5. So that doesn't have a like term. Okay, guys, are we getting this? Let's do number 3 quickly. Whoop, Logan's already ready. Logan was waiting for me to say number 3. Let me number them quickly. I haven't even numbered them. 1, 2, 3, 4. Everyone is saying 1 and 3. Okay, let's check. Number 1 has an x squared. Number 2 has number 3 has an x squared. Okay, that's correct. I need to start using a larger variety of colors here. And number 1 has a y, and so does number 3. So they are indeed like terms. So for number 3, it's 1 and 3. Okay, now I'm going to push you and say let's do number 4 as well. I'm going to push you and say let's do number 4. Let me number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3 and 5, 2 and 5, 2 and 5. Okay, let's check 2 and 5, 6 and 7. Oh, there's a lot of like terms going on here. Let's see. 2a squared, 5a squared. Okay, so far we're doing well. B squared, right? 1c, 1c. So 2 and 5 are indeed like terms. Are they the only ones that are similar? You need to look at all of these numbers. I see at least one other one that is similar to them. Nice slogan. That's number 8. It has 1c as well. And 2 B's. And 2 A's. Do you see that? So that means 2, 5, and 8 are like terms. Let's see if we can find another one. I see 3, 6, and 7. Let's check. Number 3, 1A, 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 okay? 1B, 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 that's correct. And 2 C's, 2 C's, 2 C's. So that is correct. And someone says, and 9, okay. 2 C's, I can already see that that is correct. 1B, and 1A. Is that all of them? Yes, that looks like all of them. That looks like all of them. Okay, I'm going to write these in different colors now. So our like terms are 2, 5, 8. And then our next group is 3, 6, 7, 9. All right, so what's left? Number 4 and 1, A squared BC. Nothing else has an A squared BC there. And then number 4 is just ABC and no. So we found all of our like terms and beautiful. Hello, welcome, welcome. It's okay. We were looking for like terms now. Take a screenshot, guys. We were looking for like terms, which means they must have the same variables and the same exponents. So if you look at this example, 2x and 7x are like terms, negative 5x squared and 8x squared are like terms. But I said just y and y squared are not like terms because their exponents are different. Okay. Cool. Hopefully we're all with me here. Now we're going to use the skill we just learned to add and subtract like terms. Okay, so step 1 will always be check if they are like terms. You cannot just assume, okay? So you need to check if they are like terms. That's step 1. And then when you add like terms, you only add the coefficients. Did I say anything about the exponents? Have we said anything about the exponents? I literally just said only add the coefficients. Thank you, Butlali. Which means step 3, which is actually a bonus step, is keep the same variable and exponent. Okay, let me say S and exponents. Okay, now let's get working. Number 1, are they like terms? All of them. Are they all like terms? I see we have an M everywhere. Which one is not the like term with the others? If you look at number 1, which one is not a like term? 4m squared, because it has a squared when the others have a cube. So can we add 4m squared to the others? No, because we can only add or subtract like terms. Okay. Now, we have identified our 2 like terms. Now, if there is no coefficient there, what number is there? There is no coefficient, then what number is it? It's a 1. Thank you, Wade. So here, where there is nothing, is a 1. That means when I add these, I'm going to say 1m cubed plus 3m cubed. How much is that? Nice. That is 4m cubed plus 4m squared. Is there anything further we can do here? Is there anything further we can do? No, we have added all the like terms, okay? Do not be tempted to add these 2 and then add my exponents. We're not allowed to do that. What's the only time I am allowed to add exponents? When which operation allows me to add the exponents? Let's remind each other. Anyone? Multiplying. Thank you, Wade. The only time we add exponents is when we are multiplying. So let's do number 2. Are there like terms? 4m squared n minus 7mn squared. So what happens if they are not like terms, like Butlali has told us? What happens if you get a question like this in a test and they are not like terms? What do you write on your paper? Does anyone know? Write it as it is. Beautiful. So then your answer will literally just be 4m squared n minus 7mn squared. Okay. 3. All I see is brackets by 3. And what do brackets mean? Remind me. What do brackets mean? We are multiplying. Thank you, Ed. Okay. Now, just to remind us how to multiply such with variables, remember we start with S and then N and then V. What does S stand for? I know you guys know. My S stands for? No. Okay, Wade, I'm assuming Wade wanted to say sign, which is correct. The sign, and then N, number, and V, variable. All right. That means S means we look at the signs. In this case, they're all positive. Okay, there's nothing there, so they're all positive. So then my answer will be what? 3 positives, a positive times a positive times a positive means my answer will be positive. Thank you. And then N is my number. Okay, I'm not going to write the positive. You guys just know it's positive. N is the number. There's nothing there. So as we said, if there is no coefficient, the coefficient is a 1. So it's 1 times 7 times 3. And what is that? What is 1 times 7 times 3? That is 21. Thank you. And then we move to variables. Okay, we have a M and we have a N. Let's start with the M's. I know they sound very similar, but I'm talking about these guys. M. What do we do when we are multiplying? What happens with my exponents? We are multiplying and they are the same base, so we add the exponents. So we have m squared times m squared. What is my exponent going to be? It is a 5, because once again, when there's no exponents there, there is a 1. So this is m, actually, I shouldn't skip steps, so I'm going to say m to the power of 2 plus 1 plus 2. And n, there's 2 of them. It's the power of what plus what? There's the 2 n's that I'm talking about. The answer is 3, but it is 1 plus 2 or 2 plus 1. Okay, now we write my final answer. You say 21 to the power of 21, excuse me, multiplied by m to the power of 5 multiplied by n to the power of 3. Okay. Let's move on to more interesting ones. I'm going to skip number 4. Let's go to number 6. I like number 6. Number 6. Okay, once again, we start with our symbols. Now, for the symbols, we have a positive, a negative, and a positive. A positive and a negative will give you. A positive and a negative give us what type of answer? A negative, and then another positive. That means my final answer will be still negative. Okay, so I have a negative answer. We've dealt with symbol. Okay, let's look at my numbers. 3 times 5. What's 3 times 5? 15 and times 6. 15 times 6 is negative 90. We've dealt with the numbers. Now we're dealing with variables, okay? I only have one variable and it's D. Once again, we're multiplying, so we have to add those exponents, okay? So we have to add the exponents. So it's d to the power of 1 plus 2 plus 4. So then what is my final answer? Nice. So then it will be negative 90 times d to the power of 7. All right. I want to do 8 and 9 because they are so similar. Number 8. Thank you. Number 8, what happens here? What do we remember what this is called? Where you have exponents like that. It's called, well, firstly, for number 1, we can't multiply it just with that. What is my magic word that I love using? I have an exponent and it is outside my bracket. That is true. It is called power to a power 8. That's exactly what I was looking for. But what happens with this 2 first? Not contribution, but it sounds the same. Distribution. So I'm going to first have to say 2 squared times x to the power of 7 squared. Now, if you weren't here for those lessons, distribute means you give everybody that variable. Okay, so if you have a bracket and there are 2 bases, in this case, there is a 2 and there is a x, then every single base is going to get that exponents. That is only if you are multiplying or dividing, not always. Okay. So we distributed it, so 2 squared, and then x to the power of 7 also gets a squared on the outside. And this is all times, okay, I'm just going to rewrite this because we're about to do our power to a power. Okay, equals, what's 2 squared? 2 squared is 4. And now we have power to a power. I said it too early the first time, but now there it is. Power to a power, which means what happens with these exponents? Power to a power says we must multiply. So it's x to the power of 7 times 2 and another x to the power of 7 times 2, which is 14. 4x to the power of 14 times x to the power of 14. Now we are still multiplying. So what are we going to do with my exponents of x? We're going to add them. So my final answer will be 4 and x to the power of 28. Nice, guys. Once again, if you were not here for the exponents, the lesson is there, but just a reminder, if you already have something raised to a power like a squared, and then you put another exponent above that, then you have to multiply these two. Okay. Let's do number 9. Okay, so we have most of the same things. So I'm going to start from step 2. This is 2 squared and x to the power of 7 squared. But this time we have a minus. And we're going to see how that affects our answer. Okay, minus x squared to the power of 7. Once again, 2 squared is 4, x to the power of 14, minus x to the power of 14. Now, do we have like terms here? Remember, like terms come in when we are subtracting or adding. Do we have like terms? Yes, we do. They are the same variable and they have the same exponent. Right? So let us subtract them. We said if there is no coefficient, my coefficient is 1. So this is 4x to the power of 14 minus x to the power of 14. So then my answer will be 3x. Well, giving me bits and pieces of the answer. 3x, yes, to the power of 14. We said my exponent does not change. It only changes when we multiply, like in this case. That dot means multiply. Okay. Are we good with all of this whole section? Let me zoom out before you guys give me your thumbs up and your thumbs down. That was too much. There we go. Okay, now you can give me your thumbs up. Are we good? Remember, if you don't understand, you're allowed to give me a thumbs down so that I can help you. There we go. Okay. We're awfully quiet, some of us today. I hope we're all following. Thank you. Okay. We have a brain break here, but I'm not sure if we've done it before. Do these questions look familiar to you guys? Are these familiar? No. Okay, so we haven't done it. All right. Would you rather find a rat in your kitchen or a cockroach in your bed? Strange, scary stuff. A rat in your kitchen or a cockroach in your bed? Nobody wants to answer. Oh, there we go. Everyone's going with the rats in the kitchen. Nobody wants to deal with cockroaches in the bed. Except Angel. Angel's like, nope. And Buhlali. Wow. The next one is, would you rather become an adult overnight or stay a teen forever? So either you wake up tomorrow and you're an adult, or you stay a teenager forever. Claire's like, teen, sprinkle, sprinkle. Nobody wants to become an adult. Hectic. Everyone's like, y'all look stressed. Wow. Then would you rather be a detective or a pilot? A detective or a pilot? Oh, so many detectives. Angel's the pilot. Wow, okay. Nice. Nice, Yolanda. And the last one, would you rather have skin that changes color according to your mood or have a tattoo appear every time you lie? So you either have purple skin when you are sad or every time you lie, there's a tattoo that appears on you. You don't even know where it's going to appear, guys. How often do you guys lie? You guys are afraid of... Wow. Okay. All right, guys. All right. Okay. Now, this is a misconception that a lot of us might get confused, okay, about. So I just thought I'd include it here just so that you look out for it. So x plus x, we said, is 2x and not x squared. Don't get confused. And another thing is we usually write the number first. So it's 2x as opposed to x2. x2 is not wrong. I just showed you that it's not wrong if you swap them around, but we generally write the number first. Okay. And then x squared plus x squared is 2x squared. It is not 2x to the power of 4. Remember, no changing exponents unless I am multiplying. And then the last one, a plus b is a plus b, not ab. ab means what? A times b, right? So you guys might get tempted, if you see that you can't simplify, you might get tempted to maybe write them together as one. That's not how it works. Okay. Now, let's find the sum of the following expressions, which means step A is we're going to have to find like terms. Number A, well, letter A, which ones are like terms? Which ones are like terms for A? Remember, same variable. We don't have exponents in this case. Nice. P, and it's negative 5p. You guys must be careful. And then 3q and negative 6q. Okay, let's add them or subtract them. What is just p or 1p minus 5p? 1p minus 5p. Nice, Butlali. This is negative 4p. And then 3q minus 6q. That is 6q minus 3q, excuse me, minus 6q. That is negative 3q. Okay, let's look at B. B, before we even do anything, we have to do this positive, negative over here. A plus and a minus give us what? Positive and a negative will give us a negative. So I'm going to rewrite it properly with my proper signs. Minus 3 minus x. Now, what are my like terms? What are my like terms? Nope, that's the wrong one. 16 and negative 3. Great. We're saying my symbols and I love it. 16 and negative 3. And my other set of like terms? My other set of like terms, negative 5x and negative x. Nice. Now, what is 16 minus 3? Whoop. 16 minus 3 will give us 13. And negative 5x minus another x. Negative 5x minus another x. Ooh, there's a lot going on here. Negative 5 minus x. Think of your number line. No, we're going in the wrong direction. There we go, Butlale, but you must write my x, okay? Negative 6x. All right. It's good to see. Okay, let's identify like terms. Which ones have the same variables and exponents for C? Variables and exponents. 3 and negative 7. Okay, so this one. 3 and this one, I'm guessing, negative 7. Okay, yes, they both have a F and they both have a G. Okay, next set, negative 7, this one, and 8. And my last set are the ones that are left over. So negative 13 and positive 13. Now let's start with the yellow, guys, okay? 3FG minus 7FG or GF. What's 3 minus 7? That's negative 4FG. And then the green one's negative 7F plus 8F. Negative 7 plus 8. That is plus F or 1F. And the last one is negative 13F squared plus 13F squared. Negative 13 plus, it's 0. So do I have to write 0? Do we have to write it? No, it's just gone. Okay. Okay, guys, I'm going to let you go now.